Now, I will explain the conversion of alkene to haloalkane. The first step is the formation of carbocation and halide ion. The pi bond in 2-methylpropene acts as a nucleophile by using its electron pair to initiate reactions, especially attacking electron-deficient species. When the carbon-carbon double bond of 2-methylpropene attacks the hydrogen atom in HCl, the bond between hydrogen and chlorine breaks. The carbon from the double bond grabs the hydrogen, and the chlorine from the HCl became a chloride ion. In HCl, chlorine has higher electronegativity, which creates an electrophilic site, making hydrogen partially positive and attracting other molecules. In 2-methylpropene, the double bond has 2 electrons that are attracted with the hydrogen in HCl. So one of the pi electron from the double bond breaks off and reach the partially positive hydrogen. This shown by a curved arrow starting from the double bond and pointing towards the hydrogen. This friendly move causes the hydrogen-chlorine bond to break. In the transformation of HCl to a chloride ion, the sigma electron, the one that shared in the bond between hydrogen and chlorine, stays with chlorine. This change represented by a curved arrow starting from the bond pointing towards the chlorine. The arrow shows that the electrons are now mainly around the chlorine atom, turning it into a chloride ion with a negative charge. In the reaction between 2-methylpropene and HCl, breaking the pi bond in 2-methylpropene is one of the initial steps. The breaking of the pi bond needs some extra energy to happen, and that energy is the activation energy. Breaking the pi bond slows things down because it takes some effort to break that bond initially. Once it's broken, the reaction can go on more easily, and that initial step needs a bit of kick, and that is the activation energy. Markov-Nikov's rule says that the pi bond in 2-methylpropene will join the carbon with more hydrogen to ensure the stability. This creates a balanced carbocation, a stable pause in the reaction, and it helps the reaction flow smoothly. Next step is rapid reaction with anion. The chlorine ion acts as a nucleophile and attacks the secondary carbocation that will form a new sigma bond. The formation of 2-chloro-2-methylpropane is considered fast because breaking and making bonds in this reaction doesn't need much energy, making the process quick and efficient. The curved arrow formalism, CAF, justifies how electrons move during a reaction. Each arrow shows the electron shift, explaining the flow in chemical change. That's all from me. Thank you.